Good morning. Today we are making our video for packet 7. It is due next week, Tuesday on February 10th. So we've got a week of working on it with the video. So our first page says you throw 3 darts at the board shown below. If each dart hits the board, so you get 3 darts, 3 different point values, how many different possible point totals can you score? So adding up all 3 darts. Some of us that have been working on this page have just looked at, oh, I could get 1 point, I could get 4 points, I could get 10 points. No, you've got 3 darts that you're throwing at the board, and then you're totaling them up. And we need to see how many different totals we can get. So what you're gonna want to do is you're gonna wanna make a list of those different point totals. So maybe you throw the darts and all 3 darts hit the 1. What would our point total be? 3. So maybe you have 2 hit into the 1 and then 1 hits into a 4. How many point totals would that be? 6. You're going to keep going and seeing how many 3 different points totals that we can get, right? So how many different possibilities are there throwing those darts? You throw all 3 and they hit the 1, you throw all 3 and they hit the 4, writing those out, finding the totals, counting up how many different totals there are. If we had another combination that could equal 3, can I count 3 2 different times? No, because it has to be different point totals. So I can only count a 3 1 time. If there was another way that I could have gotten to that 3, I can't count it again. I have to cross it off. So find all the different possible combinations there are with those scores. If you throw 3 darts, write them out. Okay. But you can only count the total 1 time. So if I get all 3 in the middle, 10, 10, 10, that's a 30. If there was another way I could get 30, I can't count it a second time. There will be some overlaps where we have different dart combinations that equal the same total. You can only count that total point score 1 time. All right, next page. Your neighbor Henry is cleaning up his yard for this season and has already collected 7 bags of leaves. We can't forget that he already has 7 bags. Some of us that have turned in our packet already forgot that he already had 7 bags from the get-go. We have to add those bags on. You notice that his trees have not yet lost all their leaves, and when you ask him about it, he says that he expects that as they fall, he'll be able to collect another bag of leaves every 3 days. How many total bags will he have after 57 days? So if he's collecting for 57 days, but he's only doing a bag every 3 days, we have to break it down into groups of 3, right? Every 3 days. So think about what operation we have to do. If we have 57 days, but we break it down into every 3 days, and don't forget, he started with 7 bags. So you have to include that in your answer. See if you can figure out what operation to do. And don't forget those initial 7 bags. Next page is our 5-card challenge. Some of us have found some pretty creative challenges. Kind of excited to see what we all come up with. Remember though, we can't combine 2 cards to make a new number and say the 3 and the 4 becomes 34. It's not how it works, right? We have a 6, a 9, a 5, a 4, and a 3. We can only use use those values. You can't put two cards next to each other and call it a big number. So you have to use those 5 numbers with different operations and have it equal to 5. For our patterns, I wrote on yours that this is the yellow, that light color, the red is the dark color. We need to complete the table for total blocks. So in our first figure, how many blocks are there? Say it out loud. 1. In our second figure, how many blocks are there altogether? 9. In the third figure, how many blocks altogether with the red and the yellow? 25. In our fourth figure, how many blocks altogether are there? 49. So let's look at those 4 numbers. Does anybody remember what my favorite numbers are that I said we might see a lot of in these patterns? What are my favorite numbers, Avery? Nice. Rhoda? Squares. Perfect squares. I love perfect squares. Look at these numbers. Can we figure out what they're squares of? What is 1 the square of? Rhoda? Yeah, 1 squared. What is 9 the square of? Moses? 3. What is 25 the square of? Fernanda? 5. What is 49 the square of, Vinny? Can we see a pattern? 1 squared, 3 squared, 5 squared, 7 squared. Continue the pattern to complete the total blocks. Serious, a lot of these pattern pages, we can use those perfect squares. All right, next page. All right, this page confused some of us. We need to find the area of the shaded region. So when it says area of the figure, they're talking about the whole figure. So to find the area, it's length times width. So we need to find the area of that whole figure. 12 times 10, right? The length times the width. Then we need to find the area of this amount. In order to do that, we have to take away the white area. What operation means take away? Jack? Subtraction. So we're going to find the white area, and we're going to subtract it from the whole area, and we're going to be left with that shaded area. So when you get stuff like this, you're going to do the whole area, subtract the white area, and you'll be left with the shaded area. So up top, it's the whole big rectangle. Subtract out the white rectangle, and you're left with the shaded area. The whole minus the white equals the shaded. Next page. We haven't done a sphere yet. So I'm going to help us out with our net of a sphere. It's not a circle. If we look at a ball and we lay it flat, it's not just a circle. All right? So we've got the one end, the top, and the bottom, and then we have panels like this, that if we rolled it up, it would make it into that sphere. So that's what the net of a sphere looks like. Then we need to have the formula for the surface area. That formula is 4 times pi times the radius squared. And our radius, we know, is a 9. So you need to fill in your numbers. We know pi is 3.14, or you can use the pi button. We know how to square numbers, and we know to multiply it by 4. So we're multiplying all those numbers together. Our next page is not the same. It's still a sphere, but we are not finding that surface area. This time we are finding the volume. So to find the volume of a sphere, we do 4 times pi r cubed, and we divide it all by 3. So it's a different formula for the volume. Then we have to do the math 6. 1,200 milliliters of water fill the sphere 25%. 25% is 1/4. Right? So we want to know how much 3/4 would be. So if we know 25% is 1/4, we need to multiply that up to 3/4. That's your answer for down here. Our last page, super quick because it is time for us to switch. Our last page. There are 12 items. You need to make your list. If there are 3 oranges, I should see that $1.20 3 times. There are 2 bananas, so I should see 99 cents. Or I should see the 3 oranges 3 times, 2 bananas 2 times, listing them out. Remember to find that median, they need to be in order. Smallest amount first, biggest amount last. So you can find the middle. The mean, add up all of those amounts and divide it by the 12 items. Mode, which amount do you see the most of? Right? But you need a list of all 12 amounts. If you have questions on that, you can come and see me. If you are watching this at home and you continue to have questions, come see me. This is due next week, Tuesday. Turn it in by Friday to fix mistakes. I hope you are well, and I hope to see you soon. Have a wonderful day.